supporting the show. You allow us to pay all of our humans and, where needed, provide them with health benefits, and that is kind of awesome. This week, I would like to thank by name Burry Gowan, Stephen Veit, Gordon Young, Kevin Lyle, Jeanette Wink, Nano Flips, Bora Andre Livsvol, Andrew Palestra, Venkatesh Chari, Brian Kegel, David Throg, Gerhard Schweitzer, Buzz Parsec, Zero Chill, Laurel Kedison, Robert Plasma, Jack Mudge, Les Howard, Adam Anise Brown, Joe Holstein, Frank Trippin, Gordon Duas, Richard Drum, Alexis Wanderer, M101, Felique Scoot, N through Sets, William Andres, Gold, Roland Vormerdam, Jeff Collins, and Simon Parton. And all of you who join our Patreon will have access to an ad-free version of all of our episodes. So if you're noticing ads in the episodes, go join Patreon.
Do it. Join us. Thanks, everyone, and we'll see you next week.
Bye-bye. Astronomy Cast is a joint product of Universe Today and the Planetary Science Institute. Astronomy Cast is released under a Creative Commons Attribution license. So love it, share it, and remix it. But please, credit it to our hosts, Fraser Kane and Dr. Pamela Gay. You can get more information on today's show topic on our website, astronomycast.com. This episode was brought to you thanks to our generous patrons on Patreon. If you want to help keep this show going, please consider joining our community at patreon.com/astronomycast. Not only do you help us pay our producers a fair wage, you will also get special access to content right in your inbox and invites to online events. We are so grateful to all of you who have joined our Patreon community already. Anyways, keep looking up. This has been Astronomy Cast.
You're listening to Astronomy FM's AFM radio, where real geeks get their space on. If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You're listening to AFM radio on astronomy.fm, around the world and beyond.
Coming up next, it's time for an AFM radio original program, Space Pirate Radio, brought to you by the voice of astronomy, matey. This is astronomy.fm.
The pirates are coming. The pirates are coming. The pirates are coming. You better run.
Arr, it's Space Pirate Radio time here on astronomy.fm. It is Wednesday, January the 18th, 2023, at about 9 o'clock in the evening for those of us here in the eastern portion of North America. Of course, I am Captain Marte, Space Pirate, here for you for about the next half hour or so. And, Universal Time, we're at 2 o'clock in the morning, Universal Time, Thursday morning, January the 19th. So, got about a half hour or so. We'll go along, a bunch of stuff to talk about, and see where we end up. Have you been getting out and observing? Got to mention the sun, because the sun is in the spectacular zone as far as sunspots goes right now. So here comes a link to the sunspots from SOHO, NASA SOHO. Let me put the link in.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. I'm Dr. Elena Hyde. I'll be your main host this evening, actually, and I'm joined by a special guest, Blake Nancaro, who's helping me out tonight for this broadcast. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Just a reminder, this is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World's Quirks and Quarks and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at about 2 a.m. UT, if that's more your jam. York Universe works in concert with our online public viewing program run by the Observatory team. That's right, it's running right now at this exact same time between 9 to 10 p.m. local Toronto time. To see the beautiful images and join in the live chat, you can head over to our new website at www.yorku.ca/science/observatory and follow links to OPV online public viewing, or just click the YouTube link in the schedule on the main page. It's, I know, advanced technology. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. If you have any questions or comments, or if you'd like to give us some suggestions, you can always send us an email at observe@yorku.ca. And finally, you can connect with us on Twitter, Instagram, or Facebook by searching York Observatory or Allan Carswell Obs over on Facebook, actually. All of our programs are free, but if you would like to make a donation, you can see that website I mentioned before. So let's go ahead and get started on this this fabulous Monday. We have all kinds of stuff lined up. It is Monday, the 23rd of January, 2023. I still can't believe it. We're in the future. So I'm going to go ahead and start off a little bit in the usual way, because there are some pretty important events that have happened around this this time of year. The 23rd of January is an exciting time in a lot of ways for astronomy, but it's also a very important time for remembering the Apollo 1 crew. That's right, it was January 27th, only a few days from now, but back in 1967, that the Apollo 1 crew was lost. And if you haven't heard of this yet, I definitely recommend everyone to spend some time reading up on it. It was one of the big losses in space exploration. The Apollo 1 fire and its aftermath was a huge tragedy for NASA and for astronomers everywhere. They always suspected something like that could happen, but they definitely weren't expecting it to be quite this bad. And there's a great quote, actually. I know we've been talking about the James Webb Space Telescope a lot. Right now, beautiful discoveries coming in, but there's actually a quote from NASA Administrator James Webb about this Apollo 1 fire. He says, we've always known that something like this would happen sooner or later, but it's not going to be permitted to stop the program. Although everyone realized someday space pilots would die, who would have thought the first tragedy would be on the ground? And Webb was kind of instrumental in keeping the program running after this this tragedy. It was a shocking setback with the deaths of Apollo astronauts Virgil Grissom, Edward White, and Roger Chaffee in a flash fire aboard their spacecraft during a ground test on the launch pad. This was a huge disaster, and was one that, of course, unfortunately, they got to see rather close up. There was a congressional committees after this, and they redesigned the Apollo spacecraft and did a bunch of safety culture changes. I think the famous, sort of triple redundancy checks. They were conducting a countdown simulation, actually, and this was going to be their first piloted Apollo flight. So the Apollo 1 was intended to be the first crewed mission of this Apollo program. and it could have been the end of it all right there with this big disaster. But fortunately, they were able to continue on with the Apollo program and have all of those wonderful successes that we've heard about since, of course, the lunar landings and all the good stuff that came afterwards. But it did have quite a high cost to it. They were doing this test, and the astronauts were on Apollo 1. They sealed up the hatches, and they were filling it with oxygen, actually. And that is a pretty flammable gas. So when they had a flash fire in the cabin, it was pretty disastrous, as you might imagine. The outer pad crew trying to work to get the hatches open to get them out, and it just wasn't enough. Unfortunately, they did pass away, but we can at least thank them for the security processes that we now have in place. And of course, a bit of thanks to the NASA administrator, James Webb, for getting the astronaut program through this incredibly challenging time. So on this week in history, going back to 1967, it was a sad day. I wasn't around for it, but it is a day that we should probably all try to remember. Blake, did you ever read anything about the Apollo 1 crew?
I was pretty young at the time. I was just 4 years old at the time, so I don't remember it sort of live there. 2 years later, when they landed Apollo 11 on the moon, I was watching that on television, or I think I was. But I just wanted to comment that in the Apollo 13 movie by Ron Howard with Tom Hanks, they do address that. They do talk about that. It's featured in the movie, and you actually see them. Obviously, it's a dramatic sort of portrayal, but you do see how it impacted the astronauts and the wives of the astronauts and so on. And you do see them deciding to push ahead and move ahead after implementing a number of revisions to it, like that the astronauts themselves could open the hatch. That was identified as a flaw, that the hatch could only be opened from the outside. So letting the astronauts do it when they sort of maybe suddenly became aware of a significant problem, that was one of the big changes that they made.
Yeah, absolutely. And it was kind of a a real turning point in the sense that they were able to continue with the program, but only after quite a few more safety features. And I think I saw part of the movie a long time ago, but the first time I sort of encountered this was actually reading up in some of my astronomy books. Sometimes you get a little bit of history in the background. So I first learned about Apollo 1, and I was like, oh, right. Oxygen is really really flammable.
Yeah.
And a pure oxygen atmosphere is actually one of the things that has since then been pointed to as a major cause of the accident. And of course the hatches, as you mentioned, they also took some time to actually get the hatches removed, which could have, if they had gotten the hatches off immediately, that might have been avoided.
Yeah.
But yeah, ever since then, making sure that you do have a good escape system has been rightfully prioritized. And I'm quite pleased to say that it has improved substantially since that time. But a memorable time in history, and one worth noting, although not necessarily a happy day. I do have one more. I think I won't do too many this week in space and astronomy history, but just to go a little bit more towards observational, I thought it would be fun to talk a little bit about Neptune, actually. So this show, we're going to be having a lot of chances to talk about the 2023 space events. That's why I've recruited Blake to come on and hang out for this episode. But in 1979, there was a very interesting thing happening, and it all had to do with Neptune. So Neptune, if you don't know, it's an icy outer planet. It's one of the larger planets in our solar system. It's a quote unquote gas giant. And a rare phenomenon happened in January 21st, 1979. Neptune, which is the 8th planet from the Sun, took over Pluto and became the outermost planet as Pluto moved closer due to its highly elliptical orbit. So back in 1979, Pluto was still a planet, so the good old days for Pluto fans. And this is pretty cool because not a lot of people realize when you're out there looking at the planets in the sky. Neptune is a great one if you've got binoculars or a small telescope. But Pluto's average distance from the Sun is 39 AU, but it has a very elliptical orbit. So it can actually move in and become closer than Neptune. So it's quite interesting. So Neptune's average distance from the Sun is 30 astronomical units. For the listeners out there, 1 astronomical unit is a distance from the Earth to the Sun. So we are about 8 light minutes or 1 astronomical unit away from the Sun. Neptune on average is about 30, and Pluto's average is 39. But because it's so elliptical, it can come closer than Neptune. It has a sort of Neptune crossing orbit. So if you're curious about Neptune's 30 astronomical units, you might need to build yourself a scale solar system to really get an accurate picture of it. These distances in our solar system get to be pretty extreme. But this is about 150 million kilometers or 93 million miles. It's a long, long ways away. And the interesting thing about this little jaunt in the 1979 was basically from January 21st to 1979 to March 1999, Pluto was near perihelion. And perihelion is the point on any planet's orbit where it's closest to the Sun. So all of our orbits around the Sun are a little bit elliptical. Pluto is very elliptical. So when Pluto was closer to the Sun, at its closest point to the Sun, it was actually closer to the Sun than Neptune. So if you can imagine it sort of scooting in past Neptune and getting just a little bit closer. So Pluto in 1979 was just going across Neptune's orbit. 1989, it was closer to the Sun, and then 1999, it goes sort of back outside Neptune's orbit, and now it is far outside of Neptune's orbit, making an elliptical path around the Sun. We still haven't seen a full orbit of Pluto's, so we'll have to wait a little while for that. But this is pretty fun. So. Of course, if you're not aware, Pluto did actually lose its status as a planet in 2006, and Neptune has again become the outermost planet permanently, question mark, unless there's some other planet out there that gets planet status. So I thought this was a fun one for this time of year, something you might not have suspected, I suppose. Neptune can sort of trade places with Pluto in terms of who is closer. If you're looking for Neptune in the sky right now, it is very, very low in the west. And it's a fairly dim magnitude of about 7.93. So you will have a little bit of trouble seeing it even in very, very dark skies. I would recommend binoculars or even better, a small telescope with some form of tracking if you want to catch Neptune out there in the skies. I think my favorite views of Neptune that I have ever seen, I have to say, have come from the 1 meter telescope on campus at York University. I know it's terribly biased of me, but I still love being able to actually capture the disk of Neptune. Now, Blake, I understand you do some imaging as well. Have you tried Neptune?
I don't think I've imaged Neptune, but I was thinking about it, that it is a good planet to try and image, particularly because if you want to get the color, Neptune's kind of a deeper blue than Uranus. And if you're lucky, you can get one or maybe a couple of the bright moons with it. Triton is very easy to see in a telescope, actually.
Yes, yes, so bright, bright and shiny.
Have you guys put the big scope on Uranus or Neptune?
Yes, we have actually gotten a small disk for Neptune, and as you say, you can almost, if Triton is at the right spot, you can easily catch it as well. It's not a fabulous image. If you want a really, really wonderful, clear image of the planet Neptune, you actually need to go into space, travel out to the Lagrange point, and go to the James Webb Space Telescope. So we'll tie this story together with James Webb, the Space Telescope. The image of Neptune's rings that has come in from the James Webb Space Telescope has been very, very spectacular. And of course, being 30 times farther away from the sun than Earth means that Neptune gets much, much less sun per square part of its surface. It's very, very, very cold. And it is, even though it's more massive, it's got a lot of strange properties that we don't understand, and it's just such an interesting cold place out there. But yes, we have gotten a few pictures of Neptune and Uranus as well. It's not as good as James Webb, but still a lot of fun.
Can I point out at this stage when Neptune will be closest to the Earth?
Oh, yes, absolutely. Absolutely.
So I looked it up for 2023. I'm jumping ahead here, sorry. But for 2023, on September 20th, Neptune will be at opposition. Opposition is when, if you drew a line through the sun and the Earth, the planet that you're interested in looking at would be in that line further out in space. So you have sun, Earth, and your target planet. And that means it's closest to the Earth. That means it's as big as it will sort of be in your instrument that you're viewing. With some planets like Mars, as big as it will and bright as it will be to your unaided eye. So it's a great time to look at the outer planets like Neptune when they're at opposition, or a week or two before or a week or two after, because they're big and they're bright, and it's easier to see them and easier to get details and easier to see any of those moons that you're chasing. So get out the telescope, maybe hook up the camera to it around September 20th this year to get good views of Neptune.
Absolutely. And Neptune has been sort of, I like to say underexplored, but it's really only been visited by one spacecraft, Voyager 2.
That was a while ago.
It was quite a while ago. So Neptune not having a very good set of imaging, not having a lot of detail about it, makes really every image that we can capture just that more interesting and precious, if you will. And as you mentioned, it is going to be getting very, very good later on this year. It's it's got a lot of interesting properties, 17 times the mass of Earth, but it's such a chemically different object, being composed of gases and liquids and ices. It's a really interesting place, and I think some of that mystery has been captured rather well with the Neptune ring picture from again the James Webb Space Telescope. But it's so much of it has yet to be explored. It's a mystery, and I always love an astronomy mystery. And of course, its moon, its largest moon, I should say, Triton, is very interesting as well, being very reflective. It does get quite bright. It's often sometimes confused by amateur astronomers. When you're first looking at Neptune, you might think it's a bright star or something, because it's like, oh, that can't be the moon, but it is. Triton is mostly frozen nitrogen, a water ice crust, and so it's actually makes it a very sort of reflective, if you will, shiny, a shiny object. And it's an interesting moon just in general because it has a retrograde orbit around its planet. It's actually going the wrong way around Neptune, so we think it might have been captured from, maybe it used to be, you know, a Pluto of its own at some point. But very, very interesting stuff out there at the icy edge of the solar system. And Neptune is definitely something to look forward to for your telescope and binocular viewing pleasure. I wouldn't try it with your naked eye. So let's see here. What shall we go for next? I think we'll wrap up the This Week in Space and Astronomy history, and go ahead and use our Neptune as a jumping off point, if you will, to talk a little bit about 2023 and what to look forward to this year. We've already had such amazing events in 2023. I just have to start off with the first one, and then I'll pass it to you, Blake. This year has been amazing for astronomy already. So if you didn't realize, just yesterday we had the closest part of the Venus-Saturn conjunction here in Ontario, and everywhere you can see Venus and Saturn. So on January 22nd, just yesterday, they were at their closest approach of 0.4 degrees apart from each other. So they were so close together. If you did have clear skies, you might have actually thought it was just one really, really bright star. So towards the western towards the western sunset, towards the western horizon, right after sunset, you can find Venus and Saturn together very close in the sky. Even tonight, if you saw the sun setting and something very, very bright just after sunset, there's a chance this was it. They're moving away from each other now, getting a larger distance in the sky, but it's still pretty spectacular. It's worth keeping in mind that Venus is on a tighter orbit around the sun than Earth. What does that mean is Venus orbits the sun inside the orbit of Earth. So it's kind of like if you have ever had those cars that drive around on a little track. You've got an inside track and an outside track. Well, Venus would be on an inside track and Earth would be on the outside track. So when we're looking towards Venus, we're always kind of looking in the direction of the sun. So Venus is sometimes called the evening or sunrise or sunset star, because it's so close to the sun in the sky. As long as you have, clear weather, you can usually see it. And now you've got the brightest planet in the solar system right next to Saturn, which is also not at all faint. So it is quite a treat. The clouds and snow here in Toronto have not been doing us any favors. I completely got snowed out yesterday, and today I think I caught a small glimpse of it at sunset, but just missed it. Were you able to catch at all the conjunction, Blake?
I didn't. Tonight was sort of clear where I am for St. Thomas, but I didn't have a chance to get outside, unfortunately.
Yeah, it's pretty tough. If you will still be able to see it tomorrow, so this is the good news. In the next couple days, you'll still see something bright following the sun down after sunset. So tomorrow, around 5:50 or so, edging towards 6 p.m. in Ontario, you'll have Venus at, oh gosh, about 12 degrees above the horizon, so nice and low following that setting sun down. Never look directly at the sun, no matter what you do. But once it's safe and you can look in that general direction, if you do have clear skies towards that westerly direction, it's a beautiful line in the sky. You have the sun setting, you have Saturn, which is a magnitude 0.82, nice and bright, next to, of course, Venus, which is super, super bright. Venus is, gosh, I think Venus is -3, -4 almost, -3.8. So very, very bright objects in the sky. The negative numbers are very bright. And then after that comes a lovely crescent moon. And of course, then you've got Jupiter, which is also up. And if you keep going, you've got Mars. And it's a lovely, lovely line in the sky. So if you do get some clear weather, that conjunction is still pretty awesome. Not quite as good as it was yesterday, but worth looking for. And it's very, very bright. This is something that if you have at all clear skies, you will be able to see, which is why I love recommending bright objects that people will definitely be able to see. It's a very we'll talk about the comet later because you're not going to be able to see it, but we'll talk about it.
That scene tomorrow too, if it's clear, it's great to get out the camera. When you get a bunch of celestial objects lined up like that, it's just beautiful in the photograph. So get your cameras out there, put it on a tripod, you use a medium or a wide lens for a lovely photograph.
Yes, absolutely. And I will say, even if you don't have a tripod, I have seen some of our students' cell phones produce absolutely shockingly magnificent pictures of the sky, just propped up against a railing for stability. So the cell phone technology is going the right way for amateur astronomy, for sure.
Yeah, and your car roof is a tripod too.
Yes, exactly. And anything that you can get that angle against. And it is, if it is clear, as Blake mentioned, those line of objects going through the sky is really spectacular. That line is, of course, the ecliptic. Most of you have probably already heard about that in another broadcast from this or another astronomy show. But that is the plane of the solar system that you're looking at, the plane where all of the planets orbit the sun. So Neptune is also on that same plane as is Uranus. Pluto is not quite, which is one of the reasons it was demoted, I suppose. But yes, this year in space has already been absolutely spectacular. We started off January with this lovely, bright, striking conjunction, and of course a brand new, new discovery of a comet, C2022 E3. So I figure we'll start with the new discoveries, and then we'll go into the rest of the 2023 events. I know you have some thoughts on this comet, Blake. But I'll go ahead and tell everyone what it is first. So if you haven't heard, comet C2022 E3 reached perihelion on January 14th, 2023. So it passed within 1.11 AU of the sun. So it actually got just almost as close to the sun as Earth. It was discovered in 2022, which is why its name has 2022 in it, in March, which actually was discovered by the Zwicky Transient Facility in Southern California, which is actually why you'll see ZTF added to its name sometimes. That's the Discovery Observatory. And its closest approach to Earth should be on February 2nd. So it is not visible to the naked eye. A lot of people have been getting very interested about this comet because, of course, it's a green color, and this is probably the only time we're going to get a chance to see it. There's a very good chance it will be going to the outer solar system, or maybe even leaving the solar system after this this pass through. But you will need binoculars or something to see it in the sky at the moment. It is too dim. It's, as I keep telling people, if you can't see Polaris in the city, you definitely won't be able to see the comet. It is getting brighter. It's currently listed as magnitude 5.94, which means that with reasonably good skies and a pair of binoculars, you can probably pick it out if you know where to look. Stellarium, the free Stellarium web is a great resource for showing you where it is at the moment. The brightness is still climbing. It's an interesting object with this, as I say, this lovely chemical outgassing, creating a nice green color that you can actually get a little bit of a glimpse of it through binoculars. But if you have a small telescope, this is the time to use it. So I'll go ahead and pass it over to Blake. I know you had a couple things to add about this comet.
I did, thanks. Let's have sort of a dialogue. I'm curious your thoughts on this. I've been amused and a little bit irked or unhappy with some of the media attention given to this. For example, I've seen headlines that said, this comet was last seen 50,000 years ago.
Yeah.
Now, what do you think about that? What does that make you think?
Yeah, so you do have to watch out a little bit with some of these headlines. Not seen in 50,000 years is a little bit misleading because we don't know what was going on 50,000 years ago. We have very, very few records from 50,000 years ago, and the records we do have are not complete. So we think that this comet might have passed close enough to Earth for someone to see it 50,000 years ago, according to mathematical models. But it's not really accurate to say that it was seen 50,000 years ago. It's just not quite the factual statement that as a scientist you would want to make. So you will see that coming up again and again, but we don't actually know. This is a mathematical model based on its orbit, and you do still need binoculars to see this comet. It's interesting because of where it comes from. We think it comes from the icy outer solar system. We talked about Neptune and Pluto and how incredibly cold and distant those objects are. Well, even farther out in our solar system, there's something called the Oort cloud, which extends maybe even halfway to Proxima Centauri. It could be, a light year out from the sun. And this strange icy outer region of our solar system is a very, very interesting place that we don't get to look at because everything out there is so dim and so cold and so small, we can't really see it. So if this comet is coming from that outer area, this is interesting to watch because it might tell us something about objects in that region. Comets are, of course, made of ice and dust, typically. But being able to watch the outgassing, measure it with a spectrograph, see what kinds of chemicals are actually in there, that actually is good science that we can look forward to. So from my particular perspective, I don't think we need to hype this up to make it more interesting. It's already an interesting object.
Mm-hmm. Another thing I'm curious about this, you've described that there's modeling being done that appears to suggest that the comet has been here before and now it's returning after 50,000 years. My understanding is that there are three classes or designations for comets. what we're seeing with this one is that it's preceded by the letter C, C 2022 E3. And C means that it's a non-returning comet. It's a one pass only comet. Another designation that we can have is P. The P designation represents a periodic comet, like Halley's comet. These return after 50, 100, or 1,000 years or something like that. And a new designation is the I designation for comets, and those are ones that came from outside the solar system, possibly from another solar system. They're interstellar. So my question to someone like you would be, if the modeling is suggesting that it is a returning comet and it has a 50,000 year period, how come it's not preceded by the P designation?
So I would guess, because I wasn't involved in naming it, but when it was discovered, they were able to determine that the orbit does not look like it will come back this pass.
Yeah.
So it was discovered last year in 2022, just to keep my years straight. And they were able to see it's going to come in past the sun, and then it's going to go out at this very hyperbolic trajectory. And it doesn't look like it's going to come back after this pass. So exactly what was happening 50,000 years ago, I don't think I would speculate. I haven't seen the model. But after this pass, we do not think it will be coming back. And it is interesting that some of the outgassing chemicals that they're seeing inside this comet, C 2022, actually do have some things in common with the 21 Borisov object, which we think was a, as you say, coming from outside of the solar system comet. Interstellar, I believe, is the designation.
Yeah.
So analyzing the chemical makeup of this object is really interesting, because if it did come from our own Oort cloud, the differences between this object and 21 Borisov or Oumuamua, those being outside of our own solar system, that actually already tells us a little bit about how our solar system might be unique and what kind of compositions we might be able to expect out there in that very, very low density Oort cloud that is, following our sun around the galaxy. So it is a really interesting time, and the atmosphere that was created by this comet being somewhat spectacular to look at does not hurt at all either.
Another thing that I'm a little bit perturbed by with the media is their very flamboyant, colorful descriptions or terminology around this comet, where they're describing it as this incredible green comet. And when people look at a comet in binoculars, what kind of color are they going to see? Gray.
Yes.
Or even your telescope, it's going to look gray. It would require photography to extract color, and some, not necessarily long exposures, but some good photography on a good mount. Really nice photography is done where you track at the comet's motion or speed through the sky. The stars will streak or move, but you get a lot of color then.
Yes, absolutely. And that's absolutely a really good point for all sky objects, because the fact that this is a green comet does make it interesting, but the green color is hard to see. And so 99.999% of the pictures you will see out there have been taken with cameras and then adjusted so that the color is visible. That said, I will put a little caveat. If you do have a 1 meter telescope, you do actually get a little bit of the green color through the eyepiece.
Right. Aren't you lucky? Yeah.
So you'll have to come by sometime, Blake.
Yeah. So, but then my other sort of question for you is, aren't all comets green or blue-green?
Their colors in comets are interesting. Each comet is a little bit different some comets are bluer. Some comets really don't have a lot of green in them. And it all has to do with the type of outgassing that they are doing. So it's ice and dust, but what other chemicals are present and in what abundances? So having something be strongly green is a little bit unusual. Even the 21 Borisov, it did not appear strongly green. It wasn't green enough to really be captured easily in any photographs, for instance. It just happened to have a little bit of the same chemical outgassing. And actually, in space, just in general, objects that are green are a little bit rare. Objects that are very green don't tend to naturally occur easily. They require certain chemicals to be present in high abundances. So this does make it an interesting and fun comet to watch, and I'll be interested to see what happens when it does reach its closest approach. If it actually is visible in the sky naked eye, that would be amazing. But we're not going to make any promises on this show.
My last pet peeve, and I'll get off my soapbox, is that I would kindly ask people, don't refer to this comet as Comet ZTF.
Yes.
Its name is Comet C, which is a mouthful. It's Comet C 2022 E3. And parenthetically, we refer to it as ZTF because that's who found it. There are at least 2 ZTF comets visible right now. So if you say, hey, let's go out and take a picture of Comet ZTF, if you called me up and said that, I'd say, which one? And similarly, there are several Pan-STARRS comets visible right now. I often see people saying that, oh, I'm going to look at Comet Pan-STARRS. Which one? That's like, describing something like, I'm going to drive and meet you at the parking lot and I'll pick you up. What car are you in? I'm in a Ford.
Yeah.
That's
what parking lot?
Yeah, and that's not enough. So please use,
exactly.
even though it's a mouthful, please use the full designation, or if nothing else, the year and the month discovery code, because then everybody knows exactly which comet you're talking about. Thank you.
Yes, and this is actually astronomers. It says astronomers are bad at naming things, but in this case, the name does have a meaning, as Blake was pointing out. Every part of this name actually has a specific meaning telling you something about this comet, C 2022 E3 ZTF. And so if you use all of those things together, you've got a unique object. If you forget one, you might not be referring to a unique object anymore. And I did check actually, because we were mentioning the chemical outgassing. If you are a chemistry fan, the green outgassing chemical in this particular case is diatomic carbon. So that was the one I was trying to remember last time. All right, so we have a lot of other fun objects in 2023 to talk about, so we should probably head on over there. But before we get any farther, I do have to remind everybody that you are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you are interested in joining our OPV for chat and watching the pictures, head on over to yorku.ca/science/observatory and click on the YouTube link, or go to the OPV and follow the menu. Tonight you're listening to Elena and Blake, and we are talking about the amazing astronomy of 2023. So we'll go ahead and just look for a quick I do have one quick reminder as well that we will be doing a special YouTube broadcast this Wednesday with the Teletube crew at 7:30 on the same YouTube channel that OPV is currently on. So if you would like to join in on that, that's 7:30 Eastern Time. All right, so let's without any further ado, let's get into 2023. What's good, what's bad? 2023 looks like an awesome awesome year for astronomy. I mean, every year looks awesome for astronomy. 2022 was sort of the year of lunar eclipses. To my mind, 2023 really looks like the year of meteor showers. So Blake, I'm going to hand this over to you so that we can talk about your interesting 2023 objects.
I have a big list here, but maybe what I can do is just name the date and the event. So grab your notepad, sports fans, and your pen or pencil, and I'll just go through this really quickly. But if you do have questions about a specific one, or Elena, you want to comment on a specific event, jump in.
Yes, and actually, as you're going, I believe you did say that some of this is also on your blog.
Yeah, I've got the meteor showers for 2023 highlighted. So if you head to blog.lumpydarkness.com and then you use the word tag cloud and you click on meteors, you'll find the my meteors 2023 outlook. And the Lyrids on April 22nd, the Perseids on August 12th, the Orionids on October 21, the North Taurids on November 12th, and the Geminids, on December 13th. They're all
oh yeah, that's going to be cold.
they're all looking pretty good this year. So I've rated them high or good in my synopsis. The Leonids on November 17th and the Alpha Monoceratids on November 21st, I rank them fair. And the other ones are bad for the year.
Yeah. Excellent. Anyone interested in searching that up, I do recommend checking out Blake's blog. It is an excellent list of tips on there, and I have to say I completely agree with you about the meteor shower ranking. For my money, I think we did discuss this previously, but the Perseids look like probably one of the best.
Yeah, the Perseids are always a fantastic show. And what's good about this year is there's very little moonlight to interfere. And if I remember my dates correctly, it's on the weekend, isn't it?
Oh, really? Yeah, it's August 13th. And early in the night of August 13th and early morning August 12th, 13th was the days
that's Saturday.
I saw.
Yeah, woo! It's Saturday.
That's really good.
So we can stay up late. It's good to view many meteor showers after midnight. So stay up late, and you'll get a higher count then. It's because the Earth is turning into or falling into the meteors as as we collide with them in space. So you usually get a better show or a higher count, but you got to stay up late.
Yeah, bring your lawn chairs and a warm blanket. And the time of year is also, to my mind, just perfect because in August it's not all that cold in Ontario.
Right. I also want to try the Geminids this year, and I'll bundle up. I'm going to give it a shot. Yeah.
This December is a challenge. Yes, if you are going for Geminids, that's going to be. I mean, at least the nights start earlier. But if you're going to go for after midnight, that is going to be properly chilly, I'm sure.
Yeah. So, do you want me to go through the rest of my list here?
Yeah, go ahead. How about you get as many as we can, and we'll focus on that for this show because there's a lot of amazing things going on in 2023, and I think that this will be really fun for everybody to realize just how many awesome reasons there are to look up.
Okay, so sharpen those pencils. Here we go. We've talked about the comet, but some notable dates. On the 26th of January, the comet will be very close to the Little Dipper. And if you get out the binoculars, you can look at Kokab and Furcad, the two stars at the end of the pod of the Little Dipper, and you'll find the binocular view will include the comet. On January 31st, the comet may reach maximum brightness. Some are saying magnitude 4. Some others are saying magnitude 5. Magnitude 5 puts it into eye visibility, but it still might be tough. They're small. It's a little fuzzy star. So get binoculars. That will help, or the telescope, of course. February 1st, did you mention it? It's closest to the Earth.
Yes.
So that's sort of good. And that means the actual number 1.1, 1.2 astronomical units, or 173 million kilometers. So that's pretty neat. Oh, I'm sorry, that's the wrong distance. Sorry, that's the sun distance. The distance from the Earth is 0.28 astronomical units, and that's 42 million kilometers. So
And
very,
that's
very
why,
close.
yeah, this is why we're not worried about it hitting the Earth as well.
Yeah. And it will be about 10 degrees at that point from Polaris. Also, on January 28th, a lunar X opportunity. So look at the moon. On January 30th, Monday, the moon will be very near Mars. February 22nd, we have the moon very near Jupiter. That'll be lovely in binoculars or photograph it. February 27th, once again, the moon is very close to the Mars. There's a lot of close passes this year. In other parts of the world, there'll be an occultation. The moon will block Mars, like what we had earlier a month or so ago. March 1st, Venus and Jupiter are in an oppulse or a conjunction. So like what was with Jupiter and or what's going on with Venus and Saturn right now, Venus is heading towards Jupiter, and they'll be really close together. And the cool thing about that is the two brightest planets.
Yeah,
And
0.5 degrees, I think.
Yeah, half a degree apart. So in the telescope, it's going to be fantastic. But to the eye, they may appear to merge. They'll look like one bright star. So watch it night after night, a few days before and a few days after. You'll see Venus creep up, and they might merge to your eye, and then they'll split apart. That'll be neat. So it's not a one-night only event. Whenever you get clear skies, check it out. March 23rd, in the evening again, we've got 3 planets and the moon. Mercury will come into the sky, but super low and close to the sun. We talked about be careful, don't wait for the sun to go down, but a little window of opportunity to see Mercury and then Jupiter and Venus and the moon. So that'll be neat. 3 planets and the moon. April 11th, Mercury is at greatest elongation. So that's as far as it gets from the sun. And April 11th is the best opportunity for the whole year. It'll be 19 degrees away from the sun.
Nice.
Late May, Jupiter, I just say late May because it's many nights. There are multiple moon events. So the Galilean moons will create shadows, double shadows, and do transits. And that continues into June. If you can, look at in your software or look in the RASC Observer's Handbook. And all these multiple moon events are documented. On almost any evening, you'll be able to see something interesting with the moons. And it's to do a bit with the geometry of things. The 13th of July, the moon is very near the Pleiades. So that'll be lovely in binoculars. And Jupiter is there and up and to the right. But that's a morning event. So if you're an early bird, that's a good one to check out. Mars is going to be close to Regulus 2 times in July, and they're similar kind of colors. So look at on the 10th of July and the 28th of July. They're going to be Mars will be very close on those 2 times.
Yeah, and you'll actually get it similar again in August with Antares and the moon, a little bit of action.
And they're even more closer in color there. We've talked about the Perseids on the 12th and the 13th. On August 24th, the moon will occult Antares. So again, an interesting opportunity with any instrument, eyes, binoculars, telescope, camera. Watch the bright star Antares get blocked out by the moon. That'll happen around 10:40, and then it will reemerge at 11:35. And the moon's just a crescent. It is low in the sky, but it'll be fun.
Yeah, there's a lot for August, so make sure to star that month, actually.
August 27th, we have Saturn opposition. Again, when a planet is opposition, that's really the best time to look at it because it's close to the Earth and bright. Saturn will be below the ecliptic, sadly, but it does reach a maximum altitude of 35 degrees, so not too bad. 16th of September, the moon will occult Mars. But it's in the daytime, so it's going to be fun, a fun experiment. You can see the moon in the daytime, of course, and the moon will occult Mars at 2:55 p.m. and it will reappear at 4:20. We talked about the Neptune opposition on the 20th of September. 14th of October, there's a solar eclipse, or as I like to call it, a solar occultation. And for us here in Ontario, it's only a partial. You must use the proper solar filters and safety equipment, and solar glasses, and so on. But it will start at 11:54 and conclude at 2:23 p.m. So it's a daytime event, obviously, but easily seen if you have the proper safety equipment. We talked about the Orionids. On Friday, November 3rd, Jupiter opposition, close to the Earth. November 13th, Uranus opposition, lovely pale blue color, and you might be able to see some of the moons like Ariel. And we talked about the Geminids on December 13th. That's it. That's my year review.
Oh, I'm so glad we got to get the whole year review. That's a wonderful review. I think you've gotten everything on my list, and actually I had a few extra things as well. So this is, you heard it here first, folks. 2023 is going to be an amazing year for astronomy. And a lot of these objects are really, really good with binoculars. So if you are thinking of maybe doing a bit more astronomy than just looking up with your naked eye, binoculars are a really good first step that can help you see a lot of these other objects. Now, we don't have a lot of time left, so I know we were thinking we would talk about all kinds of stuff, but maybe we'll just leave everyone with a couple little observing tips for 2023. Blake, do you have any quick top tips for amateur stargazers trying to go out and seeing perhaps a couple of these occultations and meteor showers?
Yeah, one is practice. Get out there, observe, practice using your equipment, and don't get dismayed. Just you got to keep practicing. There are skills. It takes a while to learn this, so if you buy a piano, you can't suddenly play it. You got to practice. Consider joining a club or a society, and that's for multiple reasons. Great advice. You can go to member observing nights. They maybe have telescope loaner programs. Don't get bamboozled by media hype. They'll build things up, and I worry about crying wolf situations. A very specific piece of advice: if you do have a telescope, always start with the lowest power.
Yes. Excellent. Well, I think we could probably talk for at least another several hours about fun observing tips and stuff. I'll just finish off by saying, although we don't have a lot of time left, one of the places you can look if you're interested is, of course, the RASC, the Royal Astronomical Society of Canada. They do have observing programs, which we might try to talk about later on another show, because it is about time to wrap up this one. So thank you very, very much, Blake, for coming on tonight. It has been a joy to hear all the wonderful objects of this year. I'm going to go ahead and remind everybody that you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I've been your host this evening, Dr. Elena Hyde, and I've been joined by the amazing Blake Nancaro from
Hello.
Rask Toronto Centre.
Thank you.
The wonderful list of 2023 objects. Stay tuned because it is Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western World, and Science for the People. You can always connect with us on Twitter and Instagram at York Universe, or of course see our website for show notes, content updates, and more. Thanks for tuning in. Have a wonderful, clear evening. Have a wonderful 2023, and good night.
Bye-bye.
That you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.